Hello and welcome to GCSE Chemistry, AQA, higher tier, paper 2. This time is from June 2018. So we've had paper 1, over paper 2 chemistry. So time allowed for this paper is 1 hour 45 minutes. That's a little bit of a longer paper. So ruler, calculator is needed, and periodic table, which will be given in the exam. So don't worry about remembering numbers of elements, can be given that. You have to use blue or black ballpoint pen. The reason why is because it's scanned. So when you take the paper in the exam hall, afterwards it gets scanned and emailed to people to mark. So each question could be just emailed to people. It's all anonymous. So when they scan it, they want the person to be able to read it. So that's why they ask blue or black ballpoint or ink pen. So there are 100 marks available in the paper. So important things here. So marks for questions are shown in brackets, which we'll go through each one. You can use a calculator anytime you want. There's no non-calculator parts. And also that if you show working, you can get marks for working. So even if your final answer is not correct, you can actually still gain marks for the working. Okay, so that's always a good thing to show all the working on the paper. So because even if you accidentally put the wrong number in, at the end, you can still get marks for your working. Okay, so we're going to still start. So I'm going to go to this so I can write on it. So question 1. The question is about chemicals in fireworks. So we haven't had bonfire night too long ago at the time of filming. So coloured flames are produced because of the metal ions present in fireworks. What colour flame would sodium ions produce? So that's just 1 mark. So remember, sodium ions are the same ions which give street lights their colour. So it would be yellow or yellow-orange, orange-yellow. Okay, so I'm going to write it as a yellow-orange. Okay, because it's not quite bright. The standard yellow, it's got orange tint. That will give you a mark, yellow, or if you just put yellow or just orange, you'd also get a mark for that. Because it does depend a little bit on your opinion, doesn't it, of that one, because it is a little bit in between, isn't it, yellowy orange colour. Okay, so name a metal ion that will produce a green flame. So the most obvious one is copper. Okay, but you could get marks for saying barium. Okay, that's more of an unusual one, but it does. It's a very light green flame barium, but copper is the most commonly used one because it's a more common metal. So in fireworks, it will generally be copper. So some fireworks contain a mixture of metal ions. Why is it difficult to identify the metal ions from the colour of the flame? Okay, so this one, there's only 1 mark. It's just because the flame colours mix together. Okay, because you notice that, yeah, some fireworks will be a mixture of different colours, and it's difficult to tell. So one might be just brighter than the other one, so you might not be able to tell. Okay, there could be other ions in there which we can't see. Okay, next part. Only had 1 mark answer so far, so maybe a bit more marks. Flame emission spectroscopy is used to identify metal ions in a firework. Figure 1 shows the flame emission spectra of 5 individual metal ions, the flame emission spectrum for a mixture of 2 metal ions. So this one's just showing calcium, that one's just showing copper, that's potassium, lithium, and sodium. And this one's showing the mixture of 2. So I told us 2 metal ions. So which 2 metal ions are in the mixture? Okay, this is the same question. I've just copied it twice because it's on 2 different pages, so you can see it on 1 page. So let's have a look. So it's whatever matches up. So this is a mix of 2. Okay, so you can see, you can probably just see it quite quickly, actually, can't you? Because you can see calcium isn't in it because it's missing all of those complicated lines. So calcium, not in it. Do a process of elimination. Copper, it's missing those lines there. It's not copper, because otherwise it would have those lines there. Potassium, no, that's got lots of lines. It hasn't got lots of lines in the middle like that. Lithium, that matches up, that matches up, that matches up. It matches all the lines. The lithium and then sodium fills them in. You can, because that's actually quite an easy one to see. In another exam, you might get one a little bit more, just a bit more carefully at than that one. Lithium, so it's lithium, sodium. So tick 2 boxes. That's it. A nice 2 marks there. Very easy question, that one. So the compounds in fireworks also contain non-metal ions. A scientist tests a solution of the chemicals used in a firework. Silver nitrate solution and dilute nitric acid are added to the solution. So this is a very characteristic test for silver nitrate. It's for halide ions, so it's halogens. Okay. A cream precipitate forms. Which ion is shown to be present by the cream precipitate? Okay, so it's not white, so it's not chlorine. Chlorine is white. A yellow colour is iodine, because iodine is kind of a yellow colour, if you remember that. So it's actually the one in the middle, it's bromide. Okay, you're not allowed bromine, this one, ion. Okay, so it's bromide. Okay, so bromide is the ion. You could have written Br minus, that would also give you a mark. It has to be the ion there, not the atom. Describe a test to show the presence of sulfate ions in the solution. Give the result of the test if there are sulfate ions in the solution. So for sulfate ions. Okay, so first of all, you add barium chloride solution. You add barium chloride solution. Then, so you can have any other, you can have any acid apart from sulfuric, because although that would have sulfur and it would mask the results. So add hydrochloric or nitric acid. You could have had sulfuric there as well. So could have nitric, sorry, anything. So hydrochloric or nitric would be accepted, but not sulfuric, because that's got sulfate ions. In other words, we're putting them into solution. Okay, and then you have a white precipitate formed. White precipitate formed. Okay, next question. Okay, on to 2. So it's a different topic. So it's not to do with the other ones. So if a different question, it won't be following on. So it'll be different. Methylated spirit is a useful product made from a mixture of substances. Table 1 shows the mass of the substances in a sample of methylated spirit. Ethanol, see the biggest part, methanol, pyridine, and methyl violet. Okay, what name is given to a useful product such as methylated spirit? Sometimes they call it methylated spirits, which is actually probably more helpful, isn't it? Okay, because it actually contains more than one thing. And because they're not chemically bonded, okay, it's called a formulation. It's been more precise than you could, I know you could say it's a mixture, but it's been more precise than a mixture because it's actually made for a product. It's got its own name, a formulation. Sometimes you might hear your parents or other people say it's methylated spirits. That's probably a bit more helpful to remember, actually, because it contains more than one thing. So calculate the percentage by mass of methanol, so just a bit of maths, isn't it, really, in methylated spirits. So we need to see how much methanol, 23.3. Okay, so we're just working out 23.3. So we can use our calculator to do this. And all we do is add up the rest of the constituents of it to get the total mass, plus 23.3. So it's all of it we're doing underneath here, plus 1.5, So what I've used was the numbers from there. That's all I've used there. Okay, so that's a total. So we're just working out a percentage, so total mass. Okay, so we worked that out. Obviously, to get a percentage, we times that by 100 because it's going to be a decimal. And we get 7.9%. Okay, you kind of see it's quite low. So if you've got a high number, you knew it was incorrect. Okay, then it carries on. Methylated spirit contains ethanol and is available cheaply. So ethanol is the same as an alcohol, which is actually the alcohol that's in alcoholic drinks. Okay, methylated spirit also contains pyridine, which has a very unpleasant smell, and methyl violet, which makes the mixture purple. Okay, suggest why pyridine and methyl violet are added to ethanol to make methylated spirit. Okay, actually the reason is to stop people drinking it. Okay, to stop people drinking it. Okay, because alcohol in this country, it's got a tax on it. Okay, and if you add chemicals to it to make it undrinkable, then it isn't taxed and it's cheaper. That's also another reason they add it to actually make it so people don't drink it. So if you drink it, obviously you could actually die. Okay, that's what they said. So they actually try and make it look obviously and smell horrible as well to make people not want to drink it. Suggest one use of methylated spirit. So I would say to clean things comes immediately. Okay, you can also use it as hand sanitizer. So cleaning products, I'd say, because you just get paint off things. That's often what it's used for. Also, it's used as a solvent, so things are dissolved in it for industrial processes, or fuel. Okay, because you can burn methylated spirit as well. Okay, so next question. Describe how ethanol is produced from sugar solution. Give the name of this process. Okay, so this is actually fermentation. Let's just write that down immediately. Fermentation is the name of the process. Give us 1 mark. So it is yeast is added, little fungus. Yeast is added to a sugar solution because the yeast eats the sugar. Yeast is a living organism, it's a fungus. Okay, to a sugar solution, and anaerobic respiration takes place. To produce alcohol, or ethanol in this case. Also, carbon dioxide is produced. I'll put plus CO2 just to remind you that's produced as well. Okay, so figure 2 shows part of the displayed formula for ethanol. So that's sort of like the drawn formula displayed. Complete figure 2. So you've got all your H's. So obviously going to be, they aren't any bonds because they're already saturated. So ethanol's got 2 carbons, so you don't need another carbon. Okay, so we have O, H. So that's the alcohol group. So the alcohol group is OH. Okay. So name the gas produced when sodium is added to ethanol. So sodium is added to ethanol. So that's the same as when sodium is added to water, it's hydrogen. Okay. Methanol is used to produce methanoic acid. What type of substance reacts with methanol to produce methanoic acid? Because it's an acid, it's got, let's draw it. If it's an acid, if an alcohol's got this group, that's an alcohol. An acid has got this group. Okay, so it's got extra oxygen. So it has to be an oxidizing agent. Okay. So that's the in this video, part 1. So I'm going to see you in part 2. So just stop the video here and we'll continue in part 2. Thank you for listening and see you in part 2.